Hello, hello. So this week you are going to be doing some review for some things that you guys really didn't like. Chapter 7 dealt with complex fractions. You've got rational expressions, solving rational equations, and that word rational just means a fraction, right? The worksheet that I found for you, I really like it because it's got, not only does it have the problems, but the first few pages, it reminds you how to do this. And so they've got a couple of different ways to do it. If I'm looking at this one right here, you've got complex fractions. There's crazy numbers there. And so they found the common denominator of everything. And then they multiply everything by 12, and then you get a much simpler fraction to work with. That's the method that we are going to use as we work through these. But notice they give you lots of worked out examples. It's very similar to what you would see in our book and what you did see if you for those of you that looked at the book. And then, like I said, I've got my worked out answers. I'm changing the assignments slightly. I was going to have you do 1 through 20, but they're really repetitive, so I'm actually going to have you do 2 through 36 even. It's actually going to be a couple less problems, but the way that these are worked out, they are very repetitive, and so I don't want you to just keep doing the same thing over and over again, because it's kind of just pointless busy work. So I'm cutting it down a little bit. It'll still be good practice, but it'll be more different problems. So I'm going to look at odd problems for you, and then you can do the evens. This is very similar to our book where the odds and evens mirror each other very, very similarly. So I've got 1 plus 1 over x all over 1 plus 1 over x squared. So in this case, I could rewrite this as 1 over 1 and 1 over 1, right? And if I wanted to, I could get a common denominator for my top and my bottom, and then I could simplify from there. Instead, I'm just going to look, what is the common denominator of everything? And the best denominator that I can get is an x squared. So what I'm going to do is I'm going to multiply every term by an x squared. Here, they're going to cancel completely. Here, I'm just going to be left with an x squared. Here's just an x squared. Here, one of my x's are going to cancel. So I'm going to have an x squared plus x all over, and then on the bottom here, I'm going to have an x squared. Oh, that's not plus 1. This is a minus 1. Minus 1, right? At this point, I can factor my top and my bottom, right? Whenever you're simplifying these, that's going to be your next step. That's why we did the factoring review last week, because that factoring is going to help us make sure that we have them in their most simplified form. In order to simplify this, remember, we can't cross off those x squareds as much as we want to. Remember that silly picture I put up where every time you do this, a kitten dies, right? We don't want to kill any kittens. So we want to make sure, don't be looking at these and thinking, oh, I want to cross them off. These really obnoxious addition and subtraction signs make it so that I can't just cross things off. It has to be multiplication first, which means I've got factoring to do. On the top, I can factor out a greatest common factor. On the bottom, I've got an x minus 1, x plus 1, because that's a difference of squares. So those can cancel. Now that I've got them in terms of multiplication, I can cancel them, and I've got x over x minus 1. That's going to be my final answer there, okay? And if you look, a lot of these are very, very similar. These first few ones, all you're doing is just multiplying the top and bottom by whatever that common denominator is of all of your terms. So if I look at, say, number 3, if I've got a minus 2 all over 4 all over a minus a. I want to get rid of the fractions within fractions, right? But if I do something to one piece, I have to do it to the other one as well. So up here, I'm going to have to multiply everything by an a, even though up here there's no fractions to get rid of. So up here, I'm actually going to leave this in that factored form of a times a minus 2, because that'll make it a little bit easier. And then on the bottom, I'm going to have my a's cancel, so I've got a 4 minus a squared. And so in this one, remember, this is a difference of squares, but I have to make sure, because I'm going to have some subtraction going on, I have to make sure to keep my pieces where they go. I can't just use the commutative property, because addition or subtraction is not commutative, right? 2 plus a. So these, I want to cross them off. And hopefully you remember what pops up when I cross these off. right? They're the same, but they're a subtraction and they're switched, right? So I can't just cross them off. I want to, but remember, if I cross them off, a negative has to pop up, right? So I've got a negative a over 2 plus a, or a plus 2, right? With addition, you can just switch your order, okay? Let me do another one here. Let's look at maybe number 9, because that one's a little bit complicated. It's not too bad, though. Most of these, they're not too bad. It's more just making yourself remember how to do them and then work your way through. The hardest part of these is looking at it and being scared and walking away, right? If you look at something like number 9, I'm going to zoom in on it. That problem looks complicated as heck, right? It looks like something that I don't want to do that. There's fractions within fractions, there's negative signs, there's a's in there, there's numbers afterwards that don't even have things underneath them. So it looks like it's going to be really complicated. But as soon as you start getting into it, it's really not that bad. Go out, not in. There we go. So let me write this out and let's work through it. I've got 3 all over 2a minus 3 plus 2 all over, I've got a negative 6 over 2a minus 3 minus 4. So for this one, remember, we are still going to find our common denominator. That's going to be the whole goal. The common denominator of everything here is this 2a minus 3. So I'm going to multiply every term by a 2a minus 3. Right? If I multiply it to everything, then I haven't changed my equation. So I can get rid of my 2a minus 3 here. So I'm going to have a 3 plus, and then I've got 2 times 2a minus 3. Then on the bottom, I'm going to have a negative 6 minus 4 times a 2a minus 3. Pay attention to that negative sign when you're distributing through. Remember, those things always get us. So 3 plus 4a minus 6. And then on the bottom, negative 6 minus 8a. And then that's going to be a plus 12. Combine like terms, right? I'm just still combining and simplifying as I go. So I've got a 4a minus 3 all over a negative 8a plus 6. Here I can take out, I'm going to actually take out a negative 2 so that I can get my signs to match up. So I'll have a 4a minus 3 all over a negative 2 times a 4a minus 3. Those cancel and I get a really pretty answer of a negative 1/2. That's the part that I really love about these rational expressions, is they start off so big and gross and they simplify out really nice. Most of them do. Sometimes they don't simplify out all the way. Sometimes you get to something like this and maybe it doesn't factor, or maybe nothing cancels even though it does factor, and that's perfectly fine, right? But most of them are engineered so that you get nice, pretty answers. Okay? Let's look at another one. Let's look at 17, because that's where these things start to get a little bit bigger and you've got more than one term. Or more than 2 terms in the top and the bottom. Things look a little bit more complicated. So I've got 1 plus 3 over x minus 10 over x squared. That's going to be all over 1 plus 11 over x plus 18 all over x squared. So looking at this one, my common denominator of everything, I need to pick the biggest exponent, right? If I just multiplied everything by x, it wouldn't cancel here, so I've got to multiply everything by an x squared. So x squared, x squared, x squared. You'll notice even in my worked out answers that I write those in there so that I can see what's going to cancel, right? I'm going to have an x squared plus 3x minus 10 all over an x squared plus 4x plus 18, and I believe yeah, they work. So I've got an x plus 5, and then an x minus 2, and then here, oh, that's not a 4. Where did I get a 4? That's an 11. I was going to say, that's not working. And then, did I not write it down correctly at all? No, that is correct. Oh, no, this one is a minus. See, this is where I need you. I miss you guys so much because I keep messing up, and I would not have messed up had you been here. I wrote this down as a positive, and so then I ended up with, it should have been a negative 3x, which would make it a negative 5 and a positive 2. that's really important because this bottom one factors into an x plus 9 and an x plus 2, and then those cancel. So I get my answer of x minus 5 all over x plus 9. Okay? Little mistakes can be really obnoxious. Let's look at 21, because there's some of these here where we have to make sure that we're distributing things through and that we're multiplying them properly. So I've got x minus 1 plus 2 all over x minus 4. Then I've got an x plus 3 plus 6 all over x minus 4. So this one's pretty similar. My common denominator still is just going to be this thing right here. So I've got an x minus 4, 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 x minus 4. Right, so those cancel, right? Nothing's going to cancel with here. So I've got an x times x minus 4 minus 1 times x minus 4 plus 2, right? Because those canceled completely. On the bottom, I've got an x times x minus 4 plus 3 times x minus 4 plus 6, because once again, those canceled completely. I'm going to distribute, and then I'm going to combine like terms. This looks like it's really complicated, right? But in all reality, I'm just going to do distribution and then combine like terms. The steps are not that bad, right? So I've got x squared minus 4x minus x plus 4, right? Pay attention to that negative sign. Minus x plus 4, then plus 2. On the bottom, I've got an x squared minus 4x plus 3x plus 12 plus 6. So on top, I'm going to have an x squared minus 5x plus 6. And then on the bottom, I've got an x squared minus x. And then, is that right? Yes, okay. Plus 17. No, not 17, 18. This one isn't going to factor. Yep, this one doesn't factor, and this one does, but because the bottom doesn't factor, we don't have to worry about it. We're done. Okay. Let me look at another one. Go on to the next page. Okay, so let's go with 20. Actually, I'm going to do 26 for you because that one looks really complicated, but it's not that bad. And they don't have one that's very, well, I guess 27 similar to it. So I'll do 27. I don't want to take away all of your fun, right? So 2 over b squared minus 5 over ab minus 3 over a squared. Okay. And then on the bottom, I'm going to have 2 over b squared plus 7 over ab plus 3 over a squared. So 3 over a squared, 5. And then those are addition. Okay, just making sure my signs and everything are right. So in this case, I'm looking at my denominators, and in order to have things cancel, I'm going to have to multiply by an a squared b squared, right? I can't just multiply it by a b squared or else my a's wouldn't cancel. Same thing with an a squared, so I need to have both of them. So a squared b squared, a squared b squared. And I know this part might seem cumbersome, but for me, it really helps so that I can make sure that I'm crossing things off and I recognize the pieces that are left. I don't want to have pieces forgotten about. So on top, my b squareds are going to cancel first. So I've got 2a squared, right? And then here, an a and a b are both going to cancel. So minus 5ab. My a squareds are going to cancel, and so it's going to be minus a 3b squared. On the bottom, my b squares cancel, so I've got 2a squared. My a and my b cancel again, so I've got plus 7ab. Those cancel, so I've got plus 3b squared. You looked at factoring things like this before. Remember, because I've got an a squared a, no a, and then I've got b squared b, no b. I know that I'm going to have an a and a b in the beginning and the front of both sets of parentheses, right? And then I can just look at my numbers the same way. I know that I'm going to have a 2a and a 1a, right? I know that that's going to happen. And then I'm going to have different signs, so one positive, one negative. I might have to switch those, I'm just looking at my top one first. And so I have a product of 3, and I'm going to end up with a difference of 5. But remember, one of those numbers is going to be multiplied by 2. So if I put my 3 here and my 1 here, right, I can multiply to get a negative 3b. And when I do my foiling out, I get a negative 6 plus 1. That gives me a negative 5. On the bottom, it's going to factor pretty similarly. I've got a 2a. The big difference here is that my signs are going to be the same, right? And so I'm going to have, in fact, this one is exactly the same, but my signs are positive for both of them, right? Because this gives me a 6ab plus 1ab gives me 7ab. So then these things cancel, and I've got a minus 3b all over a plus 3b. Okay? And actually, I'm just going to have you stop at 30. Yeah, so just do 2 through 30 even. We're not going to worry too much about those other ones because this is it's a kind of long assignment. So you're down to about 15 problems. It's not that much. And take your time. You can do it. If you have any questions, let me know. Remember, I'll upload my worked out answers, so you'll be in good shape. All right, adios.